Section 5.5 is really taking 5.2, 5.3, and 5.4 and shifting everything accordingly. The graph is not part of it. It doesn't say the graph. It says find an equation of the parabola. So a sketch kind of helps. The vertex is at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Again, just this is for reference, nothing more. And the focus is at 5. 1, 2, 3, 4, 5. Negative 1. This is a focus. If this is the vertex, that means the parabola opens up. That means y equal 1 over 4 times p into, and if the vertex is at 5, negative 3, wouldn't that be x minus 5 squared minus 3? So you shift 5 units to the right, 3 units down. 5 to the right, 3 down. Now, to figure out what p is, isn't p this distance? Since I'm going from negative 3 to negative 1, isn't that a distance of 2 units? There it is, done. If you understand the graphs, this is a very quick section. Extremely important. We have a vertex at 1, negative 4. 1, negative 1, negative 2, negative 3, negative 4. Right there. That means, oh, and a focus at negative 11. 1, oh boy, negative 11. Okay, that's long. Let me rescale that really quick. So again, the graph is nowhere part of this, otherwise I'll be a lot more picky. So let's say this is 1, negative 4. Got it. And this is at negative 1, negative 2, negative 3, negative 4, 5, 6, 7, 8, 9, 10, 11, 1, 1, 2, 3, and 4. Negative 11, negative 4, and this is 1, negative 4. So if this is the vertex, I know the parabola opens to the left. It is x equal. Now, again, if you're having a hard time with this, and we're going to do this for all those shiftings, I suggest you switch things around. We're not used to this. So if I was to say the vertex is at 1, negative 4, negative 4, 1, and this will work that even though you're doing double the work. Because I know the parabola opens sideways, and this is kind of hard to see. And you'll notice I'm doing a whole new problem. That's okay. It's worth doing instead of me getting this wrong. Negative 4. Again, rough sketch. Negative 4. Negative 4, 1. And negative 4, negative 11. If this is the focus and this is the vertex, this opens down. This is y equal negative 1 over 4. I'll get p in a minute. If the vertex is at negative 4, isn't that x plus 4 squared plus 1? And how am I going to figure out p? Well, p is this distance. I am running from y equal 1 down to negative 11. If I go from negative 11 to 1, isn't that a distance of 12? Guess what? All what I have to do for my actual problem is switch x with y. X would equal negative y minus 4 squared over 48 plus 1. And that'll do the trick. Next problem up. Number 6. Graph each conic. Label the vertices, the center vertices, foci, and asymptote depending what you have. This is an ellipse. My suggestion, this is only me, you really don't have to do this. My suggestion is for you to say, you know what, let me sketch a graph of x squared plus y squared over 64 equal a 1. if I want to sketch a graph of this, I know, again, this is a rough sketch. I know I'm going to move 8. So let's say that is 2, 4, 6, 8. And 1 in the x, because that's an ellipse. So the center is at 0, 0. I need to label vertices. Vertices are at 0, 8 and 0, negative 8. And the foci are at 0. Again, this is double the work. C equal the square root of 64 minus 1, square root of 63. 9 times 7, 3 radical 7. Square root of 63, a number between 7 and 8, 1, 2, 3, 2, 4, 6. We labeled that at 2, so it's right there. And right there. That would be 0, the square root of 63. Let me write it out the way the book does. We should simplify it. 3 radical 7 and negative 3 radical 7. That's simple. Now when I get to the actual problem, guess what? I already have everything labeled. Before I even graph, I know the center is at what? The center is at 0, the opposite of that, negative 1. What does that mean? Add negative 1 to all of these values. And since you don't change x, everything else matches. The vertices will be, all of these points are going to remain the same because that didn't change, so all of these are 0. And the foci are at 0 and a 0. The y, however, if this is 8, if I add a negative 1, that's a 7, negative 8, that's a negative 9, negative 1 plus 3 radical 7, and negative 1 minus 3 radical 7. Labeling is the hard part. We labeled before we even graphed. And you'll have no idea how challenging this is unless you try the problem the other way around. And now if I wanted to sketch a graph of this problem, I will say, alright, let's see. I'm going to go to 0, negative 1. So I'm going to start from here. From this point, I'm going to move 2, 4, 6, 8. 2, 4, 6, 8. I'm going to move 1 unit to the right, 1 unit to the left. I'm going to sketch the graph. And basically, I'm mimicking everything I did. I know exactly where that is, about a unit right there, and a unit right there. And guess what? Everything's already labeled. I'm done with the problem. Those are supposed to be challenging problem. Well, to the average student, we're not average. Why is that? We're Pasadena students. So here, how would I do this? I'll really work x squared. Again, you don't have to do this if you don't want to. If I had a choice, I wouldn't do this because I'll do it straight. But, you know, I've been doing this forever. If I want to play it safe, I'll sketch a rough graph. This is not part of the problem. This is the actual graph of the problem. So all of this work is extra. I understand if you don't want to do that, you don't have to. The center is at 0, 0. I'm going to move 3 in the x. 1, 2, 3, 1, 2, 3. Got him. 32, square root of 32. That's a number between 5 and 6. 1, 2, 3, 4, 5, 6. And I'll label that square root of 32. 16 times 2. 4 radical 2. And 1, 2, 3, 4, 5, 6. Anywhere in there, as long as you label it, you're okay. The graph looks like this traditionally. The focus is at 0, 4 radical 2, and 0, negative 4 radical 2. Now, if I go for the foci, oops, I labeled the wrong thing. If I take the square root of 32 minus 9, that's the square root of 23. 23 between 4 and 5, 1, 2, 3, 4, right there. 1, 2, 3, 4, right there. So this is square root of 23, and this is negative square root of 23. Now, as far as labeling, when I get to my actual graph, I know the center is actually the opposite of this, the opposite of that. What that means, take 4 and add it to all of these x values. That means the vertices are x equal 4 and the foci are at x equal 4. That's simple. And you see that negative 3? Add that to all of these y's. Well, if I take 4 radical 3 plus a negative 3, negative 3 plus 4 radical 2, and negative 3 minus 4 radical 2, and negative 3 plus square root of 23, and negative 3 minus the square root of 23. There, I got everything labeled. As far as the graph, just mimic this graph. Instead of starting at the origin, move 4, 1, 2, 3, 4, 3 down. I'm going to shift this up a bit. So we go to 4, negative 3, negative 1, negative 2, negative 3. Assuming all of these is 1, again, I'm rescaling. This is where we're going to start. So I know how this is going to go. I just did it right there. I'm going to move 3 units to the left, 1, 2, 3. 3 units to the right, 1, 2, 1, 2, 3. I'm going to move a number between, we said 32 was between 5 and 6. So go up 1, 2, 3, 4, 5, 6. So somewhere in there. And 1, 2, 3, 4, 5, 6, somewhere in there. It doesn't look like it's stretched because of the scaling. So maybe we should scale both axes. That'll look better. Sorry about that, because otherwise it's going to look as if it's stretching along the x instead of the y, which is a problem. So here, let's scale it properly. Let's do the same thing. So I'm going to move 1, 2, 3, 4. Let's go that way. And I'm going to go 3 down, 1, 2, 3. So half a unit each. That's the center. I'm going to move 1, 2, 3 to the left, and 1, 2, 3 to the right. And I'm going to move a number between, we said, 32. A number between 5 and 6. 1, 2, 3, 4, 5, 6. So right there. 1, 2, 3, 4, 5, 6. Right there. And we're going to connect that graph, and that's the actual graph. And we know the focus was 1, 2, 3, 4, between 4 and 5. Go to that middle. 1, 2, 3, 4. Go to the center, I meant. 1, 2, 3, 4. And guess what? It's already labeled. Labeling is the hard part. We already did that before we even started. And that's how we do those. Same deal with this. Again, nobody's saying you have to do any of this. You could, from the very beginning, say, you know what? Forget all of that. I don't want to do this. I know the center is at the opposite of that. Negative 3, 2. No big deal. I just need to center this. Negative 3. Why does it look that way? Negative 1, negative 2, negative 3, 1, 2. There we go. I'm going to move 4 in the x. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to move 3 in the y. 1, 2, 3. 1, 2, 3. Connect this with a smooth curve. There it is. The center is at 0, 0. The vertices, in this case, well, you gotta be careful. You are at y equal 2. You're gonna move from negative 3. 4 to the right, that's a 1. 4 to the left, that's negative 7. So again, you could do that. Just a lot of work, nothing more. And if you want to figure out the foci, well, again, they're going to be on y equal 2. I know that. And c is going to equal the square root of 16 minus 9, which is the square root of 7. So if I am here at negative 3, and I move radical 7, 1, 2 point sum, and 1, 2 point sum. Now the labeling. You're going to say I was at negative 3, I added radical 7 to the right, and negative 3 minus radical 7. You're welcome to do that if you want to. You could do that anytime you wish. You really don't have to do all of this work that I'm doing, but watch how things work. if I was to really reconsider, if I'm having a hard time with this, if I'm to consider x squared over 16 plus y squared over 9 equal 1, I start at the origin. Even though it might seem like a lot of work, I'm gonna move from the origin 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1, 2, 3. Connect them with a smooth curve. Oops. That doesn't look pretty. There's the graph. So the vertices are at 4, 0, negative 4, 0. And if I figure out the square root of 16 minus 9, that's the square root of 7. From here, a number between 2 and 3, a number between 2 and 3, that would make this radical 7, 0, negative radical 7, 0. And all what you have to say, look, add 2 to all of these values. Here they are. Take all of these values and add a negative 3. Add negative 3 to 4, that's a 1. Add negative 3 to 4, that's a negative 7. Add a negative 3, it's right there. And add a negative 3, it's right there. And you just mimic the graph. I think that's a lot easier, but that's only me.